All right, so in video 1, I ended right here finding, the combined total for his regular savings account and his Europe savings account. So we're going to calculate the total number of savings after 3 months and then also after 6 months. So essentially, we're just inputting 3. Okay, and we're also going to input 6. All right, so let's see. 105 times 3 is going to give us 315 plus the 350 they already had, or he already has. So that's $665 in his combined savings after 3 months. Okay, so after 6 months, I would anticipate, that we are now at, $980 in savings when you plug in 6. All right. Now we're going to talk about characteristics of linear functions. So remember, the domain is all possible x values that we're using. The range is all y values that we use. Okay, the x-intercept is always in the form something comma 0. Y-intercept is always in the form 0 comma something. If it's continuous, it means there's no breaks in the graph, so it's not dashed, it's a solid line. Discrete has gaps or breaks in the graph, which we don't see in either of these cases. Let's go ahead and just put arrows on the end. We're going to indicate that these go on for forever. Okay, if they go on for forever, then the domain is going to be every x value from negative infinity all the way to positive infinity, because it's getting wider and wider and wider. So we will use every value on the x-axis. This side's going up, this side's going down for forever. So we're going to use every value on the y-axis. So that would be negative infinity to positive infinity. If you were to change these two dots instead of arrows, meaning it has an end, then my domain and range would change. My domain, my lowest x would be negative 8. My highest x would be positive 8. My lowest y value would be negative 1. My highest y value would be positive 7. So again, it depends. Are there arrows on the end? If there are, it's always going to be negative infinity to positive infinity. If it's not, you're going to have to actually take a deeper look into that. The intercepts, where does it cross the x-axis, right? One of my intercepts, my x-intercept, is at 6, 0. My y-intercept is at 0, 3. So we have the x-intercept and the y-intercept. All right, we read graphs from left to right. So if you picture a guy walking from left to right, he's going downhill. So this is decreasing. All right, let's look at another example. If there are arrows on the end, then the domain is negative infinity to positive infinity, and so is the range. If we were to change these to dots, meaning it ends right there, then my lowest x value being used is negative 2. My highest x value being used is, if that hits right there, that would be 5. Range, my lowest y value is negative 8, and then you go all the way up to positive 8. All right, my intercepts. I have a y-intercept at 0, negative 4. I have an x-intercept. Let's see, that's like 1.5. It's in between 1 and 2, so 1.5, 0. You read the graph from left to right, so if you picture him walking from left to right, he's going uphill, so this function is increasing. All right, flip it over. Okay, we're going to talk about rate of change. There's definitely going to be quite a few questions about the rate of change. Okay, remember, it's just your change in y, so y2 minus y1, over your change in x. Again, change in y over change in x. This triangle symbol just indicates change. okay? Linear functions have a constant rate of change. They're constantly increasing by the same amount, creating a linear picture. Horizontal lines have a 0 rate of change. They don't change at all. Vertical lines have an undefined rate of change. Okay, so keep in mind that the rate of change is really your slope or your M value. If you look at the formula sheet for the EOC, let's see, let me grab a copy. Okay, they give you the formula for the rate of change. They just call it slope. Slope is another word for rate of change. So it's a change in y, okay, minus or over the change in x. So find the average rate of change on this function from 2 to 6. So I need to find the output for 2 and the output for 6. So let's see, f of 2 equals 3 times 2 minus 2. Let's see, that's 6 minus 2, which is 4. F of 6, 3 times 6 minus 2. Let's see, that's 18 minus 2, so 16. All right, so change in y. So we can do 4 minus 16 over 2 minus 6. It's going to be negative 12 divided by negative 4. Negative divided by a negative is a positive 3. Okay, the only other thing that I want to point out is you could have done these in reverse. You could have done change in y, so 16 minus 4. But if you did 16 minus 4, then you need to do 6 minus 2 on bottom. So that'd be 12 over 4, which is still 3. Okay, so either way, you should get that the rate of change is 3. Next, we are going to find the rate of change from year 1 to year 3. Okay, to do that, we're going to find the change in y over the change in x from year 3 to year 1, right? So I'm going to do 18 minus 5 divided by 3 minus 1, right? So 18 minus 5 gives me 13. 3 minus 1 gives me 2. Right, so I'm getting that the rate of change from year 1 to year 3 is 6.5. All right. Next example, use the table to find the rate of change between 1 and 2 and between 1 and 4. So let's start with 1 and 2. Change in y divided by change in x. So 5 minus 3.75 would leave us with 1.25 over 1. So 1.25 is the rate of change between year 1 and year 2. Then we need to go between year 1 and year 4. So 7.5 minus 3.75 divided by 4 minus 1. So on top, we are going to have 3.75. On the bottom, we have 3. So that's 1.25. What do these results tell us about the data? These results tell us that the rate of change is consistent, which we can actually look at if we take a peek at this table. It looks like we added 1.25 to get here. We added 1.25 to get here. We added 1.25 to get here. And that pattern continues. Right, so what does this tell us about the results? This is a linear function. Because the rate of change is constant. Okay, which would also make it an example of an arithmetic sequence. You're adding by the same thing every time, and arithmetic sequences are linear in nature. All right, solving equations and inequalities. Okay, so we're just going to use all of our properties to solve. We need to isolate x or get x to one side. So I can subtract 2x on both sides. Okay, remember, whatever you do to one side of the equal sign, you have to do to the other. So that would give you 2x minus 3 equals 7. I can add the 3 to the other side. So 2x equals 10, and I can divide by 2 on both sides. So x equals 5 when I solve this one. So just remember, whatever you do to one side, you must do to the other. That's even true for inequalities. But the one thing about inequalities is when you multiply or divide by a negative, it will flip the inequality sign. So let's see if that happens in this case. Okay, I can subtract 8 on both sides. So negative 4x is greater than 32. And look, I'm dividing by a negative on both sides. If you multiply or divide by negative, it's going to flip the symbol or the inequality symbol. So that'll be x is less than, and 32 divided by negative 4 will give you a negative 8. Okay, or we can solve literal equations, meaning that you might just be solving for a different variable. Right now we have solved for y, but they want us to solve for m, so we need to isolate m. I could subtract b on both sides, so y minus b equals m times x. And I could divide by x on both sides, so y minus b divided by x equals m, right? So in this case, I have solved for m, which is just isolating a different variable. They want us to solve for x, so let's isolate x. I can start with subtracting 6 on both sides, so 14 minus 6 will leave you with 8 equals ax. I can divide by a on both sides, so 8 divided by a equals x. X is now isolated, right? So I just solved for a different variable. In the last video, I'll go over this problem and the remaining 3 sections on the back.